Now move on to the how to describe the light propagation by using the Maxwell equation. Right? At first, we are thinking about the light propagation in vacuum. Okay, so in vacuum, as we've already talked about, electron displacement is epsilon 0 e, and magnetic displacement is mu 0 h, and a no charge and no current. That means rho equals 0 and I equal 0. In this case, Maxwell equations are given like this: divergence equals 0, divergence h, rho dt h. Here then the b is substituted and by mu 0 h. And the fourth equation is rotational h equal epsilon of 0 dE and dt. Here the d is substituted by the epsilon of 0 times e, right? And then so we will think about these two equations, and because it's by mixing these equations we can obtain the equation for light propagation. At first, the differentiate this equations by time. Here, what means rotational the h t equal epsilon 0 d to e so okay. Now you can substitute this h was this one. Time derivative of h can be substituted in a so rotational minus 0 e equal epsilon 0 d2e dt2. Then a little bit clean up. Rotational e equal minus epsilon 0 0 e dt2. And here we use vector analysis formula, which is rotational vector A equal gradation divergence A minus Laplacian parameter A You can check in the textbook of the vector analysis, and Laplacian parameter is equal to in the Cartesian coordinate. Like this. So what we can obtain is gradation divergence E minus Laplacian parameter of E equal minus epsilon 0 d2E d dt. You can know here is this one, divergence E, which is from this equation. Divergence E should be 0. So meaning that this one goes to 0. So final equation is epsilon 0, 0. And we assign the C as square root of epsilon 0, 0. As is obvious that this C will be the light velocity, you can imagine. So finally, we could obtain like so this is one of the most famous partial differential equation, right? And this is very familiar. The wave, which is wave, any type of wave can be described by this wave equation, and this C corresponds to the velocity in the wave equation. You could confirm that if you apply the one-dimensional case, and you can just input E equal E0 over exponential ikx minus omega t, and you could see how this equation works.